Today we're going to be working with properties of logarithms. It's section 7.5, and we are going to be simplifying and evaluating expressions along with solving logarithmic equations. In order to solve logarithmic equations, we need three things. We need the product property, the quotient property, and the power property. Product being multiplication, quotient being division, and power meaning exponents. So we're going to go ahead and jump into an example. We're going to use log base 4 of 3 is approximately 0.7925 to approximate the value of log base 4 of 192. So if you recall, it's difficult to plug something like this just into the calculator. I'm going to teach you a way to do that later on, but we have to plug things in the calculator with a base of 10. So we're given a starting point, and we're going to try to see if we can change this so it can look something like this to use what we know. So what we want to do is we want to rewrite 192 as something times 3. So we can write that 192, just on a sidebar, is 3 times 64. Okay, and when you're thinking about 64, we're still trying to use what we have here, and 64 really has nothing to do with what we have here. However, 64 does have a neat property. So 64 is the same thing as 4 cubed. 4 to the third power is 64. So we're going to rewrite this as 3 times 4 cubed. So in this line right here, all I did was I took log base 4 of 192 and rewrote 192 as 3 times 4 cubed. So here's where we're going to use the product property. And the product property says, so if you have a product right here, we can rewrite it as this. And we have this right here. So we can rewrite it as log base 4 of the first term plus log base 4 of the second term. So product property tells us that if you have multiplication inside, you can split them up with an addition sign. Okay, so we know this. We were given this in the problem, and we had this decimal approximation. So we can rewrite that as 0.7925 because we were given that. And then let's take a look at this right here. So that doesn't look like we know anything, but when you have a base that's equal to the number given here, what that's saying is what exponent does it take us to get from 4 to 4? It's an exponent of 1, right? So this is left with 1. And we're going to learn the power property, which takes this 3 and puts it out front. So this right here, the log 4 of 4 goes away, and we're left with the exponent of 3. So we can put plus 3. And at this point, I should have done the approximately equal to because I pulled in this top part. But now we can just actually add these together, and you get about 3.7925 as your answer. So to recap what we just did right here, we're taking something that we're trying to find and using what we are given in the problem to rewrite this, to rework this. It's one of the greatest things about math, I think, is that you can look at it one way, and then another person can look at it a different way, and another person can look at it a different way, and they're still equal, because this is still equal to this, but this actually helps us more than this does. So we're able to then break it apart using the product property and using the power property to actually find an approximation. Alright, so we're going to look at another example, and in this one we want to solve log base 6 of x plus log base 6 of x minus 9 equal to 2. So what's different about this one is that we've got two logarithms in there. We have these two logs, and what we want when we're solving logarithms is we want to end up having one log so that we can get rid of that. Having two makes it a little bit complicated. So the questions you should be asking yourself is, how can we turn these two into one logarithm? So it's kind of opposite of what we did last time. So if you notice between these logarithms, we have an addition sign. So if there's an addition between two logarithms, we have to think about how can we combine them into one. So in the last example, we did the product property, which took one logarithm and turned it into two using addition and multiplication. And so this one is the opposite. We're going to go the backwards way. One of the most difficult things that you might find in this section is identifying what to use where. But you'll know that product property, the multiplication goes with addition, the quotient property, division goes with subtraction, and power property, you bring down your power, and we'll talk about that later. So we can rewrite this logarithm as log base 6, because they both have a base 6. So since there's an addition sign in the middle here, we can take this x and multiply it by the other number over here, or other part. So x times this gives us log base 6 of x times x minus 9, and is equal to 2. And the reason is that we just use the product property. Alright, so now we have one logarithm, and we were practicing these last week, so we've got one logarithm with a base, and with a number here, and with this over here. So we're going to turn this logarithm into some exponential equation. So if we recall, when it has a log, the base is saying 6 to what power gives you this? Okay, so it's 6 to the second power gives you this. We can use the loop trick. So base 1, 2, 3. So it's 1, 2, 3. And we can write that as 6 to the second power equals x times x minus 9. And this is just because of the definition of a logarithm. Now we can simplify. So we're going to get 6 squared is 36 equal to, and we have to distribute because we're multiplying, so x squared minus 9x. Then I'm going to put all of my numbers on one side, so you subtract 36, you're left with 0 is equal to x squared minus 9x minus 36. And then you'll notice that we have a quadratic equation. So if you think back to quadratic equations, and we can, in order to find the zeros, where this is equal to 0, we can factor this. So when we factor, we get one factor is x minus 12 and the other is x plus 3. So now we can take those factors and set them both equal to 0, so x minus 12 equals 0, or x plus 3 equals 0, and we can solve them separately. So x is going to equal 12, or x is going to equal negative 3. And this right here was the zero product property. Okay, so let's take a look at this problem. So there was a lot that was going on in this problem, but one of the main things that I really want you to get from this is these first two big steps right here, and I think that that might be the hardest. So if you remember your product property, your quotient property, your power property, and which we will be exploring in this lesson. And if you have addition between two logs, you're going to end up taking these numbers right here and multiplying them. And it goes the other way around. So if we could even, if we said we wanted this and we wanted to break it into 2, you can go backwards also. And then once you have one logarithm on one side, you can use the definition of a logarithm to go ahead and turn into an exponential to solve from there. So I think that the main thing I want you to get from this is how to identify what property we're supposed to be using in order to solve this.